Okay, welcome to lesson 1, solve one-step addition and subtraction equations. I'm on page 437. You should also have your books out and turn to page 437. I'm going to go through the vocabulary very quickly and the essential question. Throughout the whole chapter, the essential question is going to be, what does it mean to say two quantities are equal? Well, that basically is describing an equation. An equation is a sentence stating that two quantities are equal. The solution value of a variable that makes an equation true is called the solution of the equation. So we have equation. Sometimes in our equations we have variables, and the solution to those equations are what makes it true. And when you have two equations that are equal to each other, we call those equivalent equations. The other two vocabulary we'll cover when we start doing our problems or solving our problems. So let's take a look at what our examples are going to be. Okay, first example, example 1, solve x plus 6 is equal to 4, and then check your solution. We are going to use what we call the subtraction property, which means that if you subtract on one side of the equation and you subtract the same item on the other side of the equation, it's still going to be equal as long as you are subtracting the same value. So we're going to use the subtraction property of equality to solve x plus 6 is equal to 4. So first thing we're going to do is we're going to write x plus 6 is equal to 4. And then in my classes I have you separate the two quantities. You have a quantity equal to a quantity, or a side equal to a side, or an expression equal to another expression. So the first thing I'm going to do is I'm going to solve for x. That's what we want to do. We want to solve. And I have two sides, and I'm going to use subtraction to do it. How do I know subtraction? Well, I'm trying to get x by itself. Okay, that's our first step. Okay? We're trying to get x by itself, or isolate the variable. That's another word for it. So we're going to subtract 6. That becomes 0. Okay? Okay, so if I subtract 6, I get 0. I subtract 6 on this side, I'm not going to get 0. Add the opposite here to make it a little bit easier to see this. Add the opposite. I am going to get a negative 2. So in this, I bring down the x, and I get x is equal to a negative 2. Now, don't take my word for it. Let's actually test it out. If x is equal to negative 2, then instead of x, I should be able to write negative 2 and then write the rest of it. Plus 6 is equal to 4. And that is true. If you add a negative 2 to 6, you're going to get 4. So that means that my solution is x is equal to negative 2. Let's take a look at another one. Same idea. This time the variable's on the other side. So let's write the problem. Negative 5 is equal to b plus 8. So we're going to draw our line. I need to get this to 0 because b is going to be by itself. If I get the constant to 0, b will be by itself. How do I do that? Let's subtract 8. There's another way to do it. I zero it out. 8 minus 8 is 0. So we subtract 8 over here. I have a negative 5 minus 8. Now, some students are having trouble looking at that, so let's write it out. Negative 5 Okay, so we are subtracting 8 on both sides. You have a negative 5 minus 8. We're going to add the opposite, or you could just do adding the opposite up here. So you have a negative 5 and adding to a negative 8. which is going to give you a negative 13, is equal to b. Notice that this zeroed out, so it's gone. Okay, so now you're going to test it. Does a negative 13 plus 8 equal a negative 5? Or I could write it the other way. But does a negative 13 plus 8 equal a negative 5? Okay, and yes it does. Therefore that is true. And we are going to... Okay, so go ahead and work on these two problems and then answer them and come right back.